Okay, our lesson for 1.6 today in geometry. So we've been talking proofs for the last couple of days, and really getting used to what those two-column proofs look like. So of course today we're going to change it up a little bit and show you a different kind of proof. This proof is called a paragraph proof, and that's really the big thing that we are going to focus on today. Now, paragraph proofs are a little bit interesting. They're a little bit different. They may seem easy at first. A lot of students tell me that they think it's easier than two-column proofs at first, but I always tell them to pump the brakes a little bit because they are a little bit tricky to make sure that you include everything with them. So that's going to be our main focus for today, these new proofs called paragraph proofs. Before we get there, though, we had a little warm-up. Hopefully you did it already. We notice a lot in Chapter 1 that when it comes around to the problems where you guys have to write your own equations, some of you struggle a little bit. You're really awesome at rocking out solving equations once you have them because we did that so much last year. But whenever we get to a situation where you have to write your own, you struggle a little bit. So we wanted to keep that idea fresh, and that's where this warm-up is coming from. So the warm-up says, Filippo is building a rectangular sandbox for his younger brother. The length of the sandbox is 1 foot longer than twice the width of the sandbox. The perimeter of the sandbox is 29 feet. Write an equation that could be used to determine the width, W, of the sandbox. So if you haven't tried this one yet, go ahead and do it now. Pause the video. If you did try it, I'm going to go through and kind of break it down, word problem ways. It looks like they told us what our variable was going to be. So W equals the width of the sandbox. Now, to me, when we're talking about anything like this, I see a rectangular sandbox here. I have to draw the picture. There is no way for me to do this without drawing the picture. So here's my sandbox. I got my rectangle, right? It says that the length of the sandbox is 1 foot longer than twice the width. And W is the width. So the width is here. And it says the length of the sandbox is 1 foot longer than twice the width. So twice the width would be 2W. I need 1 foot longer than that, so I'd have 2W plus 1. All right, and then after that it says the perimeter of the sandbox is 29 feet. So perimeter equals 29 feet. All right, perimeter. How do I find the perimeter? Length times width is area. Perimeter is when I add up all of the sides. Now keep in mind, I only labeled 2 sides so far, but there are not just 2 sides to a rectangle. In fact, there are 4 sides, right? So if the one width was W, I could put the W on the other side as well, and I could put the 2W plus 1 for the other length up top. So the perimeter would be when I add up all of those. So I would have 2 W's, right, plus 2 times 2W plus 1, right? 2 widths and 2 lengths. And that all added up has to equal 29. Now you could have written W plus 2W plus 1 plus 2W plus 1 equals 29. That would work as well. Now, technically the directions just said write an equation, right? It didn't say that you had to solve it. So that could be an answer. You could also have them, each of those, written out separately with a plus sign in between them. I know you guys, though. You guys are overachievers just like I am. And you want to say, but what is the width and the length? Well, let's figure this out. 2W plus 4W plus 2 equals 29. All right. So that means I have 6W plus 2 equals 29. Remember, we're showing good work here. That's our proof when we don't have to write a formal proof. Oh boy, we're going to get all kinds of messy here. I get 6W equals 27, right? And then I have to divide both sides by 6. I get W equals 27 sixths. Now, if I get my calculator out, I'm pretty darn sure I'm going to get a repeating decimal. Should I write the repeating decimal? Absolutely not. We want exact in this class unless it tells us specifically not to. So if I look at this, I can divide both of these by 3. So I would get 9 over 2, right? So I could leave my answer as 9 over 2. Width equals 9 over 2 feet. But since we are talking feet, W equals 9 over 2. Maybe I want to use a mixed number here just because we're talking feet, right? It might help us out a little bit. So that would really be 4.5 feet. It turns out that maybe did I reduce that all right? 27 divided by 3 is 9. 6 divided by 3 is 2. Oh, okay, all right. So you could write 4.5 there if you want. I thought I was going to get some kind of crazy decimal, but it turned out okay. Again, though, really, the only thing you had to do was write the equation. You didn't actually have to solve it, but I know you guys are overachievers and probably wanted to know if you did it right. All right, let's jump into our lesson for today now. So the lesson again today was about writing a paragraph proof, but I wanted to see if maybe we could link up what that paragraph proof looks like with the actual 2-column proof that goes along with it. All right, so we're going to start by seeing if you can maybe write the 2-column proof for this problem. And then after that, I'll show you the paragraph proof that goes along with it with the exact same problem so you can see kind of the similarities and differences here. Okay, so to start off with here, we have angle ABC is 108 degrees. I'm going to zoom in here a little bit and start writing my 2-column proof. So step 1, angle ABC equals 108 degrees. Given. All right. Step 2 is that ray BD bisects angle ABC. And that is also given. All right, so if I know that this angle is bisected, then step 3 tells me that I have split angle ABC, into 2 congruent parts, right? So angle ABD is congruent to angle CBD. All right, now that was one of our definitions of bisect, right, that we learned in 1.5. So I need to write a good if-then form for that definition. And remember, the if part has to be a statement before. So if something from a statement that happened before this step. So the if part would be the bisect. If an angle is bisected, and then the then part is what we're saying in this step, and that is that I have 2 congruent angles. Then it is split into 2 congruent parts. Okay. Now, what is my goal for this lesson, or for this proof? I should have probably said that at the beginning. My goal is to say that angle ABD is an acute angle. Well, I know that the big angle ABC is 108. I know that it's bisected, which means that those 2 parts are congruent. So that means it's split in half, right? So my next step then would be step 4, angle ABD equals, let's see, half of 108 is 54 degrees. Maybe you want to put a little measure in there, right? Measure of angle ABD. I maybe should have put measure of angle ABC is 108. Either way, it doesn't matter. I'm not too picky about that. All right. So how did I know that ABD was 54 degrees? Well, that was just math, right? Algebra, division, however you want to say it. I always like to use just the word algebra whenever I just do some simple math. And don't forget, you have to put in parentheses what the math is. So 108 divided by 2 equals 54, no matter what we're talking about, right? That was not specific to this problem. All right, well, if angle ABD is 54 degrees, then that means that angle ABD is acute. There we go. because we learned, and again, now here is something we have to put in if-then form, that we know from a previous step that the angle measure is less than 90 degrees, right? If an angle measure is less than 90 degrees, then it is acute. All right, so there's our 2-column proof of this proof, right? I'll zoom back out a little bit. All right, so what I'm going to do now is I am going to show you the paragraph proof that goes along with it. So the paragraph proof, and then we'll kind of give you some tips and tricks as we go. I'm not sure where exactly I'm going to put all this. I think we'll have room here though. All right, so the paragraph proof that goes along with this would start with, since, here, let's zoom in a little bit. Since angle ABC is bisected, it is split into 2 congruent parts. So angle ABD is congruent to angle CBD. This means angle ABD is 1/2 of angle ABC, so angle ABD equals 54 degrees. Since it is less than 90 degrees, angle ABD is acute. That's the paragraph proof that goes along with that 2-column proof. Exact same proof written in paragraph style compared to 2-column proof style. So what I'm going to do underneath here is now we're going to take a look at this and we're going to write some tips and tricks down. All right, there you go, for writing paragraph proofs. So what are the things that we have to pay attention to here, right? So first thing you notice probably when you're looking at this paragraph proof, you're like, holy cow, you don't have to start with the givens. You don't ever have to start with givens when you're writing a paragraph proof. When we're writing paragraph style, we're going to assume that you have just read all of that. It doesn't have that specific structure. So we're just going to say like, okay, you know that stuff. We're going to jump right into what's going on after that. So you do not have to start with givens. Okay. Notice also, I did not have to write an if-then form. And that's another thing that you do not have to do for paragraph proofs. You do not have to write an if-then form. However, we do have to write in complete sentences. So that's a little bit different, right? You do not have to write an if-then form, but you do have to use full sentences. Okay. So after that, you can kind of see how it links up, right? So notice my green step right here aligned with my green step right here. But look at what happened here. In my paragraph proof, I said angle ABC is bisected, so it's split into 2 congruent parts. So angle ABD is congruent to CBD. Notice I included the statement and the reason all in that same step, right? So look at the next one then that also aligns to the next step. Let's see if I can get a light blue here. So here, this means angle ABD is half of ABC, so it equals 54 degrees. There's your statement and your reason all in that sentence. And then if you take a look at that last one, since it's less than 90, angle ABD is acute, there's your statement and your reason all in the same sentence. So that's our last kind of tip for writing paragraph proofs. And this is the biggest one. All right, this is the huge one you can't forget, is that every sentence needs a statement and a reason. All right, and the biggest thing that people forget is the reason. So you look at this, you say, oh my gosh, it looks so much shorter. That's awesome. I want to do paragraph proofs all the time. But what happens is everybody remembers to write down what's happening, right? That I have these two congruent angles, that this one must equal 54, that it must be acute, but you forget to write the why. Why do I have two congruent angles? Why does it equal 54 degrees? Why is it acute? So that's my kind of little double trick here down below. The little double trick would be to ask yourself why and make sure that you have answered it. And make sure you answered in the paragraph proof, okay? So that's the biggest key here. Otherwise, they're not too complicated because you're used to kind of thinking in that mode from our 2-column proofs already, but you gotta make sure that you answer that question of why. All right, let's take a look at another one. Now, right now you're probably like, I don't know, if we have these 2-column proofs, why do I need to learn a paragraph proof, especially if it's tricky? Well, let me show you one here. Okay, so here's our next paragraph proof. It says, given angle A is acute, there's our little angle, sure does look acute, now we know for sure. Angle B is also acute. It says to prove that angle A is congruent to angle B. Now, probably when you're looking at this, at first you're like, oh, all right, yeah, they look like they're the same measure. But then we think a little bit farther, right? All I know is that angle A is acute and angle B is acute. Do they have to be the same measure? Angle A could be 60 degrees and angle B could be 40 degrees, right? They're both acute, but they're not congruent. So this actually can't be proven. And that's how we start this paragraph proof, is we start it by saying, this cannot be proven. And then we start writing down exactly what we just talked about. We kind of wrote our paragraph proof already. So we say, since an acute angle is any angle less than 90 degrees, there are many options for angle A and angle B. All right. But that's not enough, right? Because I could still have them be congruent. So what we need to do then is give an actual example. So we would say, for example, let's see, what did I say? I said angle A could be 60 degrees and angle B could be 40 degrees, right? Both are acute, but they do not have the same measure. So they are not congruent. All right, now I'm going to try and shrink this up a little bit just so I could write a little bit more on here. See if I can do that. Oops, missed one. But while I'm trying to do this, to get a little bit more space, notice in all of my sentences, maybe I can't shrink it. Can I shrink you? No, not so much. Okay. In each of my sentences, I had my reason, right? So I said, since any acute angle is less than 90 degrees. Notice I didn't just say there's many options for A and B. I made sure that I said why there's many options, right? Acute angle is less than 90 degrees. There was my why. Okay, and then I gave this example, but I didn't just stop at saying A could be 60 and B could be 40. They're not congruent. Why are they not congruent? Because they do not have the same measure, right? So that you have to include that why. But what we did there, when we had this crazy kind of proof that we said this cannot be proven, is we actually gave an example where it wouldn't work. So this part right here, this is called a proof by counterexample. I'm going to run out of space here to write counterexample. So a proof by counterexample is only able to be done in a paragraph form. You cannot write a counterexample in a two-column proof. It's just not possible. Can you imagine how to put that into if-then form? It doesn't work. So that's why we have to have paragraph proofs, is for these counter examples. So again, when I was talking about a counter example, what I'm talking about is this part right here. That's my counter example, where I give a specific example that does not work. So proofs by counter example have to be done in paragraph form, and that's why we have to learn paragraph proofs, because that does happen. Sometimes you can't prove things. All right, here's another example of another paragraph proof, and this might be a situation where you'd probably want to write a paragraph proof instead of writing a two-column proof. But what you've probably also noticed is, you know what, you could write these sentences in a million different ways. In fact, if I write this paragraph proof again, I probably would word it just a tiny bit differently, and that's okay. So they're a little tricky to grade and to check your own answers as well, because you don't have to have the words that match exactly. You just got to make sure you include that why. So why don't you guys take a shot at this one? So here, all I have is for a given is my diagram as shown. So notice what I've got going on here. I've got straight angle ABC split into two angles, 2x and x. I've got angle E here, which is 60 degrees. And I am trying to prove that angle DBC is congruent to angle E. That's what I'm trying to prove. Angle DBC is congruent to angle E. Now, this one seems like there's going to be some algebra going on, right? So I know that I have a straight angle, so I'm probably going to write this equation here, 2x plus x equals 180, and do a little solving, right? So whenever I have a lot of algebra, so an equation with steps to solve, a paragraph proof is actually easier to write than a two-column proof. So if you haven't taken a shot, take a shot at it right now and see what you can do. What I'm going to do is I have this proof already written out, so you don't have to sit and wait for me to write. I'm going to take a look at it with you on the next slide, and I'll point out the things that you have to have. But again, remember, everybody will probably write this in a slightly different way. So here we go. Here's the answer to the previous one. So we start with, according to the diagram, angle ABC is a straight angle. So, according to the diagram part is the why. That's the why that we have a straight angle. So make sure you have included that. That's what the highlighted things are the ones that you really need to make sure that you have. If you jumped straight into your equation without writing anything about a straight angle, then you've double missed a why, right? You definitely missed a whole statement and reason from our two-column proof. So therefore, x plus 2x equals 180 degrees, since straight angles equal 180 degrees. That seems a little redundant. You've got the straight angle in there twice. You definitely need to have, according to the diagram, and that ABC is a straight angle. So that's why I only highlighted the equation here. Then notice all I have to do is just show work. You don't have to say why you can do each step. That's just algebra. Algebra would be our reason in our two-column proof. So just show the work. So I see that I get x equals 60. So since angle DBC equals 60 degrees, since I can see that in my picture, and angle E equals 60 degrees from my picture, They have the same measure, so they are congruent. Make sure that you've included that they have the same measure, and make sure that you have stated the measure of each of them to show that they're the same. So again, the why are they congruent is that they have the same measure. You have to have those words included in your paragraph proof. So if you've practiced this and you left a couple of those things out, you'll kind of start to see why it's really easy to get those statements down. What's happening? What am I doing? But it's very easy to forget the why part of it. All right, let's take a shot at another one then. See how you do on this one. All right. Using a paragraph proof. Angle D is 90 degrees. Angle E is obtuse. Prove that angle D is congruent to angle E. Hopefully some warning flags are jumping out at you, but remember, we have to prove what we're thinking in a paragraph. So take a shot at this one. Okay, now this one is not only this cannot be proven, right? One is 90 degrees, angle E is obtuse. That means it's greater than 90 degrees. Not only can it not be proven, it is absolutely not true. In fact, it can be proven false if we wanted to. So you can either say this can be proven false, or you could say this cannot be proven. It's up to you. I went with this cannot be proven. So here's the answer. Here's the paragraph that I wrote. Again, the highlighted things are the things that you have to have in your paragraph somewhere. But it's okay if you worded it differently. So this cannot be proven. Since obtuse means any angle greater than 90 degrees, and angle D equals 90 degrees, they cannot have the same measure. Therefore, they cannot be congruent. So, do I actually need a counterexample? Not really. There's no possible way they're going to work, right? Which is what I kind of explained. If you went with a proof by counterexample, since obtuse means any angle greater than 90 degrees, that means angle E could equal 100 degrees. And angle D equals 90 degrees, so they do not have the same measure. That would be fine too. Anyway, but make sure that you have that they cannot have the same measure, right? Don't just say that they can't be congruent. You have to get that they cannot have the same measure included as well. All right, I'm hoping that you're feeling a little bit more comfortable. You kind of see what we're talking about. The paragraph proofs, the more you go through them, the easier they get, but it is always a little bit tricky to make sure you've caught all of those details. So make sure you always ask yourself, why? Did I include why? All right, so just to wrap up here, a lot of questions we get after we've learned paragraph proofs is, do we have to use paragraph proofs all the time? How are we going to know? And so here's the deal. Today, on your homework, on your practice from this lesson, you're going to use a paragraph on every single proof. But after that, the only time I want you to use a paragraph proof is when the directions specifically state that we need to use a paragraph proof in the directions. Otherwise, use a 2-column proof every time. You'll do better. You'll get them more correct. It'll be easier to grade, but there are those specific situations where we need paragraph proofs, so that's why we have to do this lesson. Paragraph proofs are necessarily because those cannot be provens are the ones that we have to do with a paragraph. That's why we got to learn it, okay? Don't forget to ask yourself, have I included the why? Okay, so then your homework is right down here, page 37 from 1.6, and you also have some extra practice there. Just remember when you're looking at the answer key, that's one way to do it. Your sentences do not have to look exactly the same as the answer key, but make sure that you've included those whys whenever you have written a statement.